Good morning, everybody. It is Tuesday, January 18th, and this is our Do Now. A student is investigating Newton's law of force and acceleration. The two identical carts are used with two different masses. The students apply different forces to each cart and then calculates the cart's acceleration. If we calculate the cart of cart A and cart B, what do we discover? Well, we do know that, I'm gonna pop a text box in here. That force is equal to mass times acceleration. And if I don't know that one, if I say, okay, if I want to find out what is acceleration, that is force divided by mass, which we have. And then I have mass is equal to force divided by acceleration. So there we go. But the one I really want is this middle one right here for this problem. Okay, and so if I take 50 divided by 1, I get 50, and if I take 100 newtons, the force, divided by 2 kilograms, the mass, I also get 50 meters per second squared. So, sometimes these things can match up. Well, let's take a look at our learning targets. I will use Newton's second law of motion to calculate force, mass, or acceleration of an object. I can draw the triangle, I can calculate, we can do that. So here's a quick review. This is slide 20 from our digital notebook from Friday. And it has those formulas right here. It has the triangle. So you may want to keep this slide up in the background so you can do it. We're going to look at the worksheet. Now let me show you where this worksheet is located. So every day you're absent. Right here, it will be a recording of the lesson. Now today, there will be a recording put in that says 1:18:22, and it will actually be what I'm doing right now. So it will always be here. So you can always start and stop and pause these, okay? Coming back here, you can always answer the Do Now. You can participate from home because see, look, it's popping up right here. I would always recommend you come down and you find it. So here is today's Do Now. Here is a copy of the Do Now. Here's the copy of the slides for today, but they don't have the narration. Those are always found in the recording. And then the worksheet that we're doing will actually be located, let's see, where is it here? Let's grab that. Oh, there we go. So it'll be right there. Now, I'm no longer going to label these absent. If you weren't here, it's going to show up and you need to complete this worksheet. So it will be here for you to do. So let's take a look at the first problem together because that's something I really want to take a look at with you. Oops. Where'd that all go? Don't tell me to close that. All right, here's the directions on top. Sir Isaac Newton's second law of motion states that the amount of force is necessary to move an object is equal to the object's mass multiplied or times by the acceleration. So F equals ma. In this equation, force is measured using newtons, N, mass is measured using kilograms, kg, and acceleration is measured using meters per second squared. All right, so that's the thing. So in each one of these problems, what you're going to do is you're going to try and figure out use this one, what you need. Well, right here, look, first I have a mass and then I have an acceleration. So that would be, I'm going to pop in a text box over here because it's a little easier for me today. So I'm going to bring down another text box here to kind of, let's move this on over here so you can see what's going on. So the first thing I have is I have 2,000 or 200 kilograms, kg. And then I'm going to multiply that times 5 meters per second. And I'm going to use the little caret because that says that I should raise that 2 up, 2. Okay? And when I multiply these, it's pretty simple. When I multiply 200 by 5, I get 1,000 newtons, capital N. Okay, so now what I'm going to do is I'm going to come over here, and I'm going to use my pencil again, and I'm going to draw these in. Now, do I put them anywhere? No. This 0 here is in my ones. So I'm going to draw the 0 here in the ones, I'm going to draw the 0 here in the tens. I'm going to draw the 0 here, write it here, because that's what I have here in my answer. I'm going to draw my 1, and then I'm going to color as best I can these little dots. And that's what I'm going to do. Now, all I want you to do is to simply set up these problems in this format, and then you can use your calculator, or you can use your phone or anything to come up with the math. We're not asking you to do that. Oops, that went away, sorry. You'll have that back. So it'll be there when you look at the tape. We have a couple more to go through. And then lastly, so we have this one here. It says Norman wanted to bowl a strike, but to do so, he caused his bowling ball 5 kilograms to accelerate. So I have mass and I have acceleration. So you need to multiply those again. On this one, you're going to have to multiply, you're going to have to take the force and divide it by the acceleration and figure out, they want to, how much force is acting on a cart when the student measured an acceleration of, so first of all, 2.6 meters per second squared. Oh, so you have to figure all these out to try and figure out what would be closest to that and to come up with the answer and choose it here. Now on the worksheet here, you're just gonna, on the A, B, C, D ones, you're just gonna highlight those, the highlighter, and our exit ticket. A student used a magnet to move a 0.025 kilogram metal ball. The magnet exerted a force of 5 newtons, which caused the ball to move. What's the acceleration when it began to move? So what it is I take my newtons, 5, divided by 0.025 kilograms. So let's do that really quick here. Let's set that up so you can see what that is. So and it says to include it. So I want 5n divided by 0.025 kg equals, oops, not plus, equals, move that down. I'm going to come over to my handy dandy calculator, and I'm going to pull up, I'm going to plunk in 5 divided by 0.25, and that gives me 200 meters per second shift squared. So that's our answer. So that's what you would need to do to show us your work. All right. So I'm hoping that you have a great day, and we will see you all Tuesday or Wednesday or Thursday.